Okay, second half of reviewing for test 4. We're going to start with number 26, which is the beginning of the log equations part of the test. On number 26, you've got log base 5 of 5x minus 1 equals 3. If you're solving a log equation, but there's only one log, the best thing is to just turn this into an exponential equation. So you're going to have 5 to the third power equals 5x minus 1. So 5 to the third equals 5x minus 1. And then solve it for x. 5 to the third is 125. Equals 5x minus 1, and then get the x by itself. So add the 1 to both sides. So you have 126 equals 5x. And then divide both sides by 5. And you can enter this one as a decimal. X equals 126 divided by 5 gives me 25.2. Number 27. Log base 3 of c plus 18 minus log base 3 of c plus 8 equals log base 3 of c. So I've got logs all over the place on this one. I can simplify the left side though, right? If I have 2 logs, I can simplify that into one logarithm using this sign to tell me what to do. Since it's minus, I'm going to turn it into this one over this one. So I've got log base 3 of c plus 18 over c plus 8 equals log base 3 of c. Since I have log base 3 on both sides, I'm just going to divide it off to cancel it. So that cancels. Hey, Dylan. Hello. So now I have c plus 18 over c plus 8 equals c. Since I'm solving for c here, I've got a c in the denominator, which means I need to multiply both sides by this denominator to cancel it. So I've got c plus 8. C plus 8, so that cancels. So now I have c plus 18 equals, when I distribute the c to the other side, I have c squared plus 8c, number 27. So now I see that it's quad. So we'll move these 2 terms over here. So I'm going to subtract c and subtract 18. So now I have 0 equals c squared. Put the c's together. So I have 8c minus 1c, which is 7c, minus 18. Now I could either factor that, or since it is quad, I can go to my quad program and enter my A, B, and C, which will be 1, 7, and negative 18. Enter. And it gives me 2 and negative 9. But remember, you don't want to use any numbers that are going to make your log negative. So don't use the negative 9. Just And then just put it in quad. Number 28. Log base 2 of x plus 2 plus log base 2 of x minus 2 equals 5. So this time, right, since it's plus, when I simplify it, it's going to be x plus 2, x minus 2. Equals 5. So now I do just have a single log. So I do just want to turn that into an exponential equation. So I'm going to have 2 to the 5th power with x plus 2, x minus 2. Yeah, so now 2 to the 5th power is 32. So when I distribute here, x times x gives me x squared. The outer is minus 2x. My inner is plus 2x. And then 2 times negative 2 is negative 4. The x is canceled. So now I've got x squared minus 4 equals 32. So again, it's quad, so I need to move the 32 over. So I'll subtract 32. So 0 equals x squared minus 36. And I can put that in quad if I want, but this is not a bad factoring problem, right? It's a difference of perfect squares. So it'd be x plus 6, x minus 6. Now, if I set those equal to 0 and solve them, this solution would be negative 6. This one would be positive 6. And don't use that negative. $29. All right, suppose that $17,073 is invested at an interest rate of 5.7% per year, compounded continuously. If we are compounding continuously, we're using this formula. So let's see what we know. We know that we start off with 17,073 and the interest rate is 5.7%. The first thing it wants me to do is just come up with the exponential growth function. So P of T equals, this is going to be our ending amount when we start using this function. This right here is my beginning amount, which is 17,073. Then the E. The K is the interest rate in decimal form. So I need to move it 2 places to the left. So it'll be 0.057. T. Then the next several parts to this problem are just giving us, they're all saying the balance after such and such year. The first one says, what's the balance after 1 year? Which means I'm replacing the T with a 1. So I've got 17,073E to the 0.057 times 1. And then you'll just put that in your calculator. What is on the right side? Just put exactly like you see it in your calculator. So 17,073. Remember where the E is. It's this LN button, but second first, right? So you can get that E. So second LN will give me the E, and it also puts me up in my exponent. So in my exponent, I'll put 0.057, open parentheses, 1, close. Now remember, on this test, you are always going to be wanting to see where it wants you to round. So this wants us to round to 2 decimal places, which gives me 18,074.43. After the 3 is a 0, which means I don't need to round up. All right, now there's 3 more of those. I'm just going to jump straight to the last one, right? They're doing the same thing every single time. It asks you then the balance after 2 years. So you just replacing this with a 2. Then the balance after 5 years. Replace that with a 5. So let's jump to the last one where it says the balance after 10 years. So again, all you're doing every time is replacing the T with the number of years. And then putting it in your calculator. So again, exactly this in your calculator. So 17,073 E to the 0.057, open parentheses 10, close. Enter. So this one, if we round it to 2 decimals, after that 62 is a 3, which means I don't need to round up. So after 10 years, I've got $30,189.62. All right, the last part of this question says the doubling time is how many years? Doubling times formula is always the same. It's ln of 2 over the interest rate. So this one will be ln of 2 over 0.057, and we are rounding this to 1 decimal place. So ln of 2, close, doubling time. So ln of 2 over 0.057, rounding to 1 decimal. So 12.16, which means we'll round that to 12.2. All right, last one on the test 4 review. Thirty questions on test 4. Oh. All right, this last one is that problem where it gives us the data table that shows the percent of adults married in a country is currently declining. So let's see. So since we are now we're going to use the exponential decay method, which all that's changing is that you're going to have now a negative in front of your rate. So let's see, in year 1960, 68.2% of adults were married. 1980, 59.5, 2000, 56.1. 2010, 44.5, and 2012, 41.1. So it says to use the data for 1960 and 2012 to find the value of K. So there's 1960, there's 2012. So let's fill out this formula all that we can so that we can find this K. So let's see, this is always on the left side is the ending amount. What is the end amount of percent of adults married? 41.1. This is the beginning amount. The beginning amount of percentage of adults married is 68.2. Then your E. to the negative k. I don't know what k is, but I do know what t is, even though it doesn't just outright tell me, because I know it took from 1960 to 2012, which is 52 years. So we're solving for k. Let's see, the first thing I want to do is get rid of the 68.2. So I'll divide by it. So let's see, on the left now, I've got 41.1 over 68.2 equals, on the right, I have e to the negative 52k. So I just went ahead and multiplied that. Now I want to bring the exponent down, so the k is where I can solve for it. To bring it down, I'm going to use that log function. So I'm going to ln both sides. That now tells me I can bring that negative 52k down. So I've got negative 52k times ln e. And what's ln e equal to? 1. So in order to get this k by itself, I just need to divide both sides by this negative 52. That'll cancel. There's my k. And then just put all this in your calculator. When you type in ln, it's going to give you an open. Make sure you close it after that 68.2. So ln 41.1 over 68.2. And then again, make sure you close it. And then divide by negative 52. Which gives me 0.0097. So that's going to be the k in the formula. So that's going to help me figure out the rest of the problems. So let's see, the formula that I'm going to use from here on out is going to be m of t equals 68.2 e to the negative 0.0097 t. So that I'm going to go ahead and write that up here because that's what we're going to use. So the beginning is 68.2 e to the negative, that's where your 0.0097 comes in, t. Because the next question says in 2015, blank % of adults will be married. So 2015, we're looking for this. What % of adults will be married? Which means, what am I finding? How many years after 1960 is 2015? 55. So that's what my T is. So I have 68.2 E to the negative 0.0097 times 55. And then just put this in your calculator and round it to 1 decimal place. So 68.2 E to the negative 0.0097, open parenthesis, 55, close, enter, rounding to 1 decimal place. So you have 40.00, so it'll just be 40. Then it wants to know in 2018. Right, so now we're just finding M of 58. So same thing, you're just using the 58 instead of 55. So 68.2 E to the negative 0.0097, open, 58, close, rounding to 1 decimal. So let's see, I've got 38.85, which means I'll have 38.9. The last part of this problem says, at this decay rate, in which year will the percent of adults who are married be 34%? So now what do I not know? I do not know the year, so I don't know the T. I do know the end amount, right? The end amount, which is what goes on the left, is 34. Equals 68.2 E to the negative 0.0097 T is what I'm solving for. So again, get rid of the 68.2. So on the left, I've got 34 over 68.2 equals E to the negative 0.0097 T. So now you want to bring down this exponent. So you're going to ln both sides. That'll bring down the exponent. So now you have negative 0.0097 T times ln of E. But remember, that's 1. So what do I need to divide by in order to get that T by itself? Negative 0.0097. So there's my T. And this one, we're rounding to the nearest whole number. So let's see. ln, it's going to open your parenthesis for you. You'll close it after the 68.2. So ln of 34 over 68.2, close. Divide by negative 0.0097. Enter. Oh, what did I do? You can. I think I entered some kind of decimal or something. So rounding to the whole number, if it's 71.7, that means 72. That doesn't make sense for the year, right? It's asking what year. So what do I need to do? This represents the number of years after 1960. So I have 1960 plus 72. So it would be the year 2032. All right, switching over to the final exam review. The only thing that's due this Sunday is review for test 4 and test 4. Okay, the review for the final exam is not due till the following Sunday, May 8th, I think. In the final exam will be due May 8th. I'll send out an email on all that. All right, your final exam will be 25 questions, multiple choice. Question 1. Graph the function f of x equals x cubed plus 4. So you could obviously just put that in your y equals, right? X to the third plus 4 and graph it. Remember, it's multiple choice graph. So remember what that x cubed shape is. It's that squiggle line. And what does this plus 4 do to it? Shifts it up 4. So you will be choosing the graph that has that x cubed shape shifted up 4. Right, number 2. Find the function value. Right, f of x equals 3x squared minus 5x plus 7, and it wants me to find f of negative 3. Okay, so what does this mean to do? That means to go and replace your x's in this function with negative 3. So if I do that, I'll have 3 times negative 3 squared minus 5 times negative 3 plus 7. And then you can just put this exactly how it's written in your calculator. So you would just do 3, open parentheses, negative 3, close, squared, minus 5, open, negative 3, plus 7. So again, exactly like it's on the board. Enter. It gives you 49. Number 3. Is this the graph of a function? So what am I going to use? That vertical line test. That's what you use if you're given the picture of a graph and you need to know whether or not it is a function. Okay, so remember what the vertical line test says is if you draw a vertical line, which is this line right here, and you touch the graph more than once, then it's not a function. But if you can only touch it once with any vertical line, then it is a function. It doesn't matter where I put a vertical line on this graph. I can only touch it once, which means, yes, this is the graph of a function. Right, number 4. Number 4 is a systems of equations in 3 variables. So let's see, we're going to have 3 equations. My first one is x minus y plus 2z equals 9. My next one is 3x plus z equals 3. But look how they put where they put that x. Make sure when you write it that you put the x over here in the x column so that you will see that there's no y. Okay, because they put the 3x right here. Make sure you put the 3x in the x column. 3x plus z equals 3. And then the last one is x plus 3y plus z equals negative 6. So what I'm going to do is use my matrix function in my calculator to solve this. In matrix A, I'm going to use the numbers or the coefficients of this left side. So it's going to be 1, -1, 2, 3, 0, 1, 1, 3, 1. So I'm going to put that in matrix A. Then in matrix B, I'm going to put the right side. So it'll be 9, 3, -6. So going to your matrix function, which will be second. There's matrix. And you need to go over to edit. And you're going to edit A. Tell it you want it to be 3 by 3, right? Because there's 3 rows and 3 columns. Okay? You'll put that all in matrix A. Then you'll go second matrix again over to edit. Make sure this time you go down to B. Enter. And this time you want it to show 3 rows, 1 column. And then enter the 9, the 3, and the -6. And then just hit second, quit. Now remember to solve this, you're going to do matrix A to the -1, matrix B. So you'll just hit second matrix, enter for matrix A. Then hit this X to the -1 button to give it the -1. And then second matrix, make sure you go down to B, enter, enter. There is your X, your Y, and your Z. So 0, -3, +3 are your X, Y, and Z. Work. You probably put it in. Here's the thing: it's a multiple choice. So what you get. Oh, see that E? That means this whole thing. So if you see that E, yeah. Okay. Number 5. For the function represented in the graph, find the domain. And remember, the domain is which values? The x's. All right, so here is my function. It wants me to find the domain, which means the x values that are included in this function. So what is this one's x? Yep, that one's -4. What is this one's x? Positive 4. And it includes all the x's in between there, right? Because there's no break. So the domain is from -4 to +4. All right, graphing inequalities. So 6x minus 9y is greater than or equal to -4. The inequalities were while we were graphing the line, two things. You want to be able to know whether it's a dashed line or a solid line. So if it has these equal to bars, you are going to connect the points with a solid line, which means that's what I'm going to do with this one. So the first thing I got to do is get that y by itself. So minus 6x from both sides. So now I have negative 9y is greater than or equal to, just bring these down since I can't combine them. So negative 6x minus 4. Divide both sides by -9. What happens to this when you divide by a negative? It flips, that's right. So you're going to have y now is less than or equal to a negative over a negative, turns it positive. This 6/9 will reduce to 2/3. However, even if you don't reduce it, it's still going to graph the same thing. Again, negative over a negative is a positive 4/9, and that one doesn't reduce. So go to your y equals, put in 2/3 x plus 4/9. And then graph it. So it is a line, which means I just need 2 points to see where this line is. When I go to the table, I got a lot of decimals in my y's. That's fine. You just need to get the shape of the line. So let's see, I'll just plot 2 points where x is 0 and x is 1. When x is 0, I have 0.444. When x is 1, I have 1.111. So let's plot those 2 points and connect them. So when x is 0, left and right 0, up 0.444. This one, to the right 1, and up a little more than 1. And remember, we're connecting with a solid line. And after we connect it, then we have to shade it. So what does this say? It wants to know where the y values are less than this line, or in other words, not above it, but the y values are less than it below it. Number 7. We're just going to go to 8 today. All right, number 7. A ladder is resting against the wall. Here's my ladder. Here's the wall. The top of the ladder touches the wall at a height of 9 feet. So the top of the ladder touches the wall at a height of 9 feet. So that side is 9. find the length of the ladder if the length of the ladder is 3 feet more than its distance from the wall. So the ladder is going to be 3 feet more than its distance from the wall, which means this side is going to be X and this side will be 3 feet more than that. So X plus 3. And then we're going to use the Pythagorean theorem. So A squared plus B squared equals C squared. Just make sure that you put this side, the X plus 3 side, on the right. Okay, so let's see, either one of these can be A and B, it doesn't matter. So 9 squared plus X squared equals X plus 3 squared. So let's see, 9 squared is 81 plus X squared equals, I'll have to FOIL this. So let's see, X times X gives me X squared plus X times 3 is 3X. I enter, and last, 3 times X is another 3X, and 3 times 3 is 9. And then I need to put my X's together over here. So I have X squared plus 6X plus 9. I'll just drop the right side down. So it looks quad, but I have X squareds on both sides. So just subtract them off. So those cancel. So now I have 81 equals 6X plus 9, solving for the X. So get the X by itself. So subtract 9. So now I have 6X equals 72. Divide by 6. So X equals 12, which is going to be one of your options. But the question is, what is the length of the ladder? This is the ladder side. So I need to add 12, right? So the length of the ladder is 15 feet. Number 8. Number 8 is finding the domain of a rational function. A rational function is a function that has x's in your denominator. F of x equals x squared plus 13x plus 40 over x squared minus 1. So remember, when we're finding the domain of a rational function, the only thing that we're concerned about is the denominator. So we need to find its zeros because that's what we need to exclude from the denominator. I mean, from the domain. So let's see, x squared minus 1. If I set that equal to 0, I can either put this in quad or I can factor it real quick, right? It's just a difference of perfect squares. X and x for x squared, right? Plus 1, minus 1. What is this one's 0 going to end up being? Negative 1, positive 1. And it says to put it in interval notation. So let's see, I want to include everything from negative infinity to positive infinity, except -1 and +1. So my first interval, this one, will be negative infinity to -1, in union with this middle interval will be -1 to +1. And my last interval will be 1 to infinity. All right, we will wrap up the review in the next